Hi! In this lesson, we're going to talk more about object literals and object properties. In a prior video, we created our first object by initializing an empty contacts object, then adding contacts to it with our bracket and dot notations. One may ask, if we knew we wanted these contacts in our object upon creation, couldn't we just initialize the object with them in it? And the answer is yes. Basically, we want to create our object like this from the get-go. To do this, we are going to look into what's called the object literal syntax. Here is our blank object. To create it with key value pairs already inside it, we type in the key name, colon, and the value we want associated with it. If we want more than one key value pair, we put a comma after the value and then repeat the same structure on the next line. We do this until the last key value pair, where we don't have a final comma, but then close the object with a curly bracket. This establishes our object with 3 key value pairs ready to go. This syntax of creating an object with key value pairs, separated by commas and closed within curly brackets, is known as the object literal syntax. This is the most straightforward way to create an object. Applying this syntax to initialize our contacts object, we'll go through the following progression. Start with blank object, then add the first contact. Add a comma, and then the next entry. Then one more comma, and our third entry. Notice that we need to include Georgia May in quotes as the key, since it is more than one word. This lets the computer know that both words belong to the key. Alternatively, you could use something like a hyphen instead, in which case you don't need quotes, and you'd be able to use the dot notation to access that key value pair. Either way works. So there you have it, a beautifully initialized contacts object with name and number starting in it. Now, if you think about it, almost all information can be organized in key value pairs. Take a look at these 2 car objects. They are individual entities with unique information or properties stored in key value pairs. In programming, we call key value pairs like these the properties of an object. For example, saying the car's color property is white is the same thing as saying the value associated with the car's color key is white. Object properties describe the state of an object, the current condition of the object at a given moment in time. One of the powerful aspects of storing information in an object is that if you want to know a value of a property, like the color of a car object, you don't need to know where the information is kept, like you would with an array, but just what the property is called, color. For example, with this car object, if we add console.log car1.color and run the program, we'll get white. Let's hop over to the editor to see an example in action. We'll start by defining our first car object. We'll label this car1, and our first property will have make, and this make will be a Tesla, comma, and then model 3, color will be white, and the year of the car will be 2020. And I end this with a closed curly bracket and a semicolon. And I'm going to copy this first car and then rename it to car 2 and change some of the values. So we'll make Subaru, the model, Impreza, color red, and year 2018. So here we have 2 objects created with the object literal syntax with properties already built in and ready to go. Now, that doesn't mean we can't add properties after the fact as well. So let's add a weight property to both cars using the dot notation. So car1.weight equals 4,000, car2.weight equals 3,000. Let's print the car1 weight just to make sure that we did this correctly. And you can see that 4,000 printed, so this looks good to go. We can also send in objects as arguments to functions so that we don't have to repeat code. So let's write a print weight function that will print the make and the weight of each car. So we'll call the function print weight, and we'll send in car1, and then we'll do the same thing for car2. Now let's define the function. So the name is print weight. It's going to receive a car object as a parameter, and so we can just label it car. And then we'll write the print statement using that car object name. So we can say console.log the plus car.make plus weighs plus car.weight plus pounds. And now you see when I run this that each object is sent into the function and the appropriate properties are printed with the appropriate cars. Hopefully you're beginning to see now how useful objects can be when we want to gather information about individual items.